Here's pre-calc. It's problem 10-25. It says sketch an ellipse centered at the origin with focal points at 0, 5 and 0, -5. Make a point P on your ellipse and label it with coordinates x, y. Well, the very beginning, before you read letter A, doesn't give you enough information to be able to graph the whole ellipse. Just so you know that kind of threw me. The only thing it gives you before you read letter A is just the focal points, which is 0, 5 and 0, -5. But there's a lot of other things that we know about ellipses that we don't need this problem to give us. Like we can just look in the math notes box. For instance, we know that the equation of ellipse is x minus h squared. This one's centered at the origin, so I didn't bother writing x minus h and y minus k. But it's so I can just write it as x squared over a squared plus y squared over b squared equals 1. Actually, I found out that this ellipse ends up being, I should have known that by looking at the focal points. This ellipse ends up being kind of a, what do we call, like a vertical ellipse. Its major axis is a vertical line rather than a horizontal line. So it's really x squared over b squared y squared over a squared equals 1. But we don't have all the information that we need yet. This is some information that we already knew. We know that in an ellipse, we know that a squared minus b squared equals c squared, and we also know that c is the distance from the center to the focus. So when they gave us 0, 5 and 0, -5, at least we know that c is 5 because that's the center. Okay, and we know that a squared minus b squared is 5 squared. So it's not till letter B that we find out that the string used to create the ellipse is 15 units long. We need that information. So I guess what I'm saying is, if you just try to sketch the ellipse without reading A, B, and C, it's not really possible because they didn't tell you how long the string was until down here. Now, you could just do this problem by, I don't know, sketching like just guessing about the ellipse. Like you wouldn't really know these points. And then you can set up the equation. This equation right here comes from the distance formula. See, like this distance, we know that if it's a piece of string, we know that this distance plus this distance has to equal 15 because they told us the string was 15. And we also know, oh, I shouldn't have said 2a. In this case, it's 2b. But we know that if I put my point P right here, then the string, it'll be equidistant here and here. So that would be 2b or 2a, depending on the shape of your ellipse. So I can use that information if I go ahead and read ahead and get this thing plotted, and then I'll go through there. This is kind of like the derivation of a formula that they like to use. But so if I know that the string is 15, then I know 2 times A, or in this case it's 2 times B, is 15. So we got 7.5. So basically the A and B are just like the bigger number and the smaller number. Okay, so I squared it out, and then I was able to solve, you can probably understand that, I was able to solve for B. Okay, so that's 5.59. So B is the shorter, I guess just think of B as the shorter one and A is the longer one. So 1, 2, 3, 4, 5.5. So I plotted that, and then now we know the longer one's 56.25, so that is 7.5, 1, 2, 3, 4, 5, 6, 7. So anyway, now I have a picture finally. And so I can follow the directions it wants me to write an equation for the sum of the distances from point P to each of the focal points. So like I said, we know the distance formula comes from Pythagorean theorem, and it's y2 minus y1 squared plus x2 minus x1 squared. And you take the square root, and that's the distance. We know our distance is 15 because that is the length of the string. So I just made a random point P. I usually make it up right up here somewhere. And I'm going to take the distance, use the distance formula on these. So I used these ordered pairs, see? I plugged them in here. So y2, that's my y, minus y1 plus, this is x2 minus x1. So that's this piece. And then this piece here, I'm using my distance formula again. So it's y2, and I just called this y2 again. y2 minus y1, so that's why it has a plus sign, because it's minus negative 5. And then x2, which is just x, minus x1. So this part came from this distance, and this part came from this distance, and we know that those are the pieces of the string. The string adds up to 15. So now it's just algebra all the way on down the line. So algebra. What did I do? I took this and squared it out, so I know that I can square the first thing, and then I go the first thing times the second thing times 2, and then the last thing squared. So you can put this in a little area model box if you don't remember how to square stuff out, but like I'll just do this one time and then the rest of the time I'm not going to do it. But y minus 5 times y minus 5, that's y squared minus 5y minus 5y. These two make negative 10. So this is, that's just what I'm doing to all these square binomials, is I'm squaring them out in my mind. Okay, and then this one is just x squared plus, so you take the first thing and square it, and then the first thing times the second thing times 2, and then the last thing squared, and then this is just x minus 0 squared. So hopefully that makes sense. Then I moved on down to here. I moved this second one over to the right hand side so that I could square out, so I can get this by itself and square it. So see, I went 15 minus this, and I'm squaring both sides. That made the square root leave the left hand side. The right hand side, I squared it out. It's a binomial. So you take the first thing squared, and then the first thing times the second thing times 2, that's where the negative 30 came from. And then the second thing squared, just the square root sign comes off. And I noticed at this point that I got this cancellation, some of the terms left. Okay, and then so I brought this 225 over to the left-hand side of the equation with my 10y. And I brought what's left over here down. And then I divided out, or I subtracted the 10y. See how that became a negative 20? Because I subtracted 10y on both sides. And then I saw that I had a 30 here. I want this by itself because I'm going to square again. So I divided both sides by negative 30. That just turned into 2/3 because, well, that's what that fraction is. And then 225 divided by 30 is this number. And I'm going to square both sides to make these come out of the square root. Square both sides. Woo! And then, oh, maybe I should show so you can see what happened. See. Sorry. Okay, so I'm squaring this, and when I square this side, see, everything just came out of the root. And then when I square this, it's the first thing squared. So that's where the 4/9 y squared came from. And then this thing, the first thing times the second thing times 2. And I actually did 2/3 times 15 halves just to make sure that turns out to be 5. times 2, that's where the 10 came from. And then 15 squared, well, this is 15 over 2 squared. And that's equal to all this. And then I saw my 10y's were going to cancel out. Oh, and then I said, well, where am I going with this? So I'm trying to get a 1 on the right-hand side and get the y squared and x squared on the other side. So what I did was I moved all the things, all the non-constants, like all the x's and the y's to the left and all the constants to the right. So see, like I subtracted y squared on both sides, I subtracted x squared on both sides, I subtracted 225 over 4 on both sides. And then, so when I combine these together, I get negative 125 over 4. And then when I combined the 4/9 and this is like 9/9, I got negative 5/9. Then I started writing in pencil because I was afraid I was going to mess it up after all this hard work. I knew I needed a 1 over here. And so I'm going to multiply by the reciprocal of this. I don't know if you can see that, but it's in pencil. And then I multiplied this side by the reciprocal. I multiplied both sides by the reciprocal of this number so I could get my 1, because I know that the formula has a 1 in it. And then when I multiply this, I just distributed some 5s and 125 canceled out. And I didn't even cancel them out. I got this. And then over here I got multiplied and got that. Okay, so now I know that I need to have the y squared on top and some number on the bottom. So I multiplied by 1125 over 20 here. Well, 1125 divided by 20 is this number. Okay, and then the reciprocal of 4 over 125 is 125 over 4. Well, it turns out 125 over 4 is this number. So ta-da, we got the numbers. Because I can check in the answer key and those numbers match. Then I want my x squared first, so I switched them around. So that, did we do it? It says, see how far you can get rewriting your equation from part B in graphing form. So we got it. That's all. Have a good day.